everyone, this is problem 65 of Neetcode 150 Task Scheduler. So let's read the problem. We're going to be given an array of CPU tasks, and every single character inside this array is going to be a value ranging from capital A to capital or upper Z. And we're also given an integer n. Each cycle allows the completion of a single task, and task may be completed in any order. And we are also being told that the only constraint is that any identical tasks must be separated by at least n CPU tasks. Okay, so for example, if we start with x, it's going to take a time of 1, and now we can only wait two more cycles before we start another x, but we can start a y. So we're going to start a y, so we're going to have x, we're going to have y, and then after this, we are going to have to wait another cycle because we need to wait 2 cycles. So we're going to basically have x, y, space where we do nothing, then x, and then y again. And this is going to take us 5 CPU cycle, okay? So for example, let's take this. We start with our A. So we are going to do our A here. And now we have to wait 2 cycle before rendering another A. All right. And we can do another task in the meanwhile. So here we can write B. What sorry for this. And we can also write C here. Right, but important point is that we're gonna have to also wait for 2 more cases before rendering another B. So after this A, we can add or other B, and notice that we can achieve all of that, right? If our n is 2, so we have to wait 2 cycles before rendering an identical task. So we can do this in basically 5 CPU cycle. Okay, so how do we actually code this? What kind of data structure are we going to need for that? Well, we are going to use DQ, and we're also going to use a max heap. Okay, so let's say that for this example, our n is still 2. We are going to create our max heap. And inside our max heap, we are going to be willing to store not the characters, but we are going to be willing to store the count of each of these characters. So we can see that A occurs 2 times, B also occurs 2 times, and C occurs only once. All right, so we will be willing to create a max heap that will look just like this. Okay, and we basically know that the top value is the most frequent element. So we know that we should initially take that top element and place that in our CPU cycle. So we should process this one first. So we're gonna put that in our DQ. So we're gonna put this 2, and also we have to take the time into account. Okay, so all right, so initially after taking that first 2, so let me just take that 2 manually, place it here. Okay, but actually we don't want to put a 2 in here. You'll see why, but just for the sake of completing this, so let's say that our time is 1, right? Because our first cycle, so at time 1 is taking this 2, and we are gonna have to reduce this by 1 because we proceeded once. So let's just delete that and write 1. And run has been proceeded at time 1, right? So now it can only be proceeded at time 1 plus n, so at time 3. So we are going to store inside our DQ basically the value of the amount of cycle that we have to or the amount of time that we have to proceed it, and also the time that, or the next time that it can be proceed at, and also our our max heap is going to be modified. Okay, so after this, we are at time 2, and we are going to check if we can actually put this value 1 here back in our max heap. Well, no, because we're not at time 3, so we're going to have to take another value. So we're going to take that 2 here, and we are going to decrement this to 1. All right, and also for this next value to occur, well, notice that after we proceeded this 2, we are at time 2. So the next time that it can be proceeded is at 2 plus that value 4, so that value 2, right? So n plus time, and it's going to be at 4. Okay, so we're going to add this in our DQ as well. And now we are left with value 1. So we are going to put this 1 here, and we are going to remove it, right? So this is one cycle. But since we are going to go from 1 to 0, we actually don't need to put that in the DQ because we are done with this task, right? We just proceeded task C. This is what that one represented. And we are going to update our time. So our time is going to pass from 2 to 3 because we just did another task. And now we are at time 3. So we can actually add, to the max heap. Well, we can add to the max heap this task and actually proceed it. Right, so now it used to be 1, so we are going to remove it, but we're going to remove 1 to this task. It's going to go at 0, so we are done with it. No need to add it in the deck. And we are at time 4, and now we are at time 4, which is the same as the time at the first value of the deck. So we can put that first value of the deck and actually proceed it in the CPU. All right, so we are going to proceed this value in the CPU, but it has a frequency of 1, so it only has to be passed in the CPU once to be completed. So it's going to go to 0, and it's going to bring us to a time of 5. Okay, and this is our final answer. Notice that in Python there is not a native max heap function. So what we're going to have to do is that we are just going to put a negative sign to all these values, and we're going to create a min heap, meaning that the top value 2 is still going to be at the top, but it's going to be shown as a -2, right? So -2 is still going to be it's going to be the lowest value, and it's going to be at the top of the min heap tree. All right, so let's go ahead and code this. So first, what we want to do, it's basically create a sort of hash map to get all the characters and their frequency. And let me be a little bit lazy here. I am not gonna do the more formal way to create a hash map. I'm just gonna use counter and set that we want to do this to task, and this is basically going to create our hash map. So for in our previous example, we will associate the key A to the value 2 because it has it appears twice in the string, and we will associate C with 1, right? So this is how we do it. And then we want to create our max heap. And what we want to do is basically to insert all the values for the keys inside count. So we're going to say for C and T in count, and now we want to reach the values, not the keys. So we have to specify this. And we also want to make sure that they are negative. So I will just say negative C and T. So basically, max heap is going to be an array of all the frequencies of each characters multiplied by -1. So after this, we can create our min heap because this is a function embedded in the heapq library. So we're going to say heapq that heapify, and we want to heapify max heap. All right. So now we have our min. We have our min heap. Now let's create the the time, which will initially be at 0. And we're also going to be willing to create our deck like this. So now all our variables are completed and we are ready to actually to do the algorithm. So the algorithm is gonna need a while loop. So we are gonna be willing to while until there is either a value in the max heap or a value in the queue, right? So if both are done, it means that we completed every single task, so we can render the time at this moment. And for every single round, we want to ensure that we are incrementing the time by 1 because we are proceeding another task in the CPU. And now this is where we want to check if there is a value in the max heap, right? Because the max heap at this time might be empty and the queue might still have some values to proceed. So we are first going to check if there is something in the max heap. And if there is something, we're going to be willing to actually get the new frequency. And notice that since our values are negative, the way that we're going to pass from like having a frequency of 3 and now we ran it in the CPU, so it has a frequency of 2 as it has already been proceeded. The way we're going to do that is by adding 1 because we have negative values, right? So if a frequency is 2, it's going to be inserted in our max heap here as a -2. So by adding 1 to it, it's going to become -1 and eventually it will become 0. And if it becomes 0, it means that it has been entirely proceeded and we can just say good, it's done. No need to put more efforts on this character. So what we're going to do is that if there is something in the heat map, we are going to create our account, which is basically going to be 1 plus the value that we're gonna pop from the max heap. So we're gonna pop a value using the library heap queue again, and we're gonna use the function heap pop, right? We're gonna pop from the max heap. And after this, it is possible that count is 0. So if it is 0, we don't want to do anything. So we're just going to check if there's something. So we're going to do this by saying if cnt. And if count is not 0, well, we are going to append to our queue the count. So how many times left do we have to proceed this task? And we're also going to add the time that we are at plus n. So it's going to tell us when is the next time that we can actually proceed this task. Okay, so that's it for all the things you have to write within if max heap. Now we can check what is the first, what is at the index 0 of the queue. If that index 0 actually can be preceded, we're going to add this to the max heap. So we're going to do this by the following way. So we're going to say if there is first a deck, so if there is a queue, and also the queue at the first element, so at index 0. And recall that at the index 0, we are going to have two values. First one is going to be the count. Second one is going to be the time. So we want to reach basically the index 1, which is going to give us the time. So if this is equal to the current time, it must mean that it can be preceded. So we're going to say heap q dot heap push. And we want to push in max heap. All right. And what is the value we want to push from the max heap? Well, we want to push the value that we're going to pop from the left of the queue. So pop left. And we want to take the frequency. So it's going to be at the index 0 within that value that we just popped, okay? And after this, once we break the while loop, it must mean that the max heap and the queue are completed. So they are empty. So we can return the time. And this is going to be the entire solution for this problem. So if I didn't do any mistake, this code should work perfectly fine. And there you go. Awesome. So I hope you learned from this video, and I hope to see you in the next video.